computer. Okay. Hi, everyone. Okay, so we have one presentation for sure, right? Do we have more than one or just one? Uh, two? Three? Okay, three. Okay, we're catching up finally. I also brought the um, um, I also brought um, the graded midterms. So we'll look at them maybe a little bit later. Uh, so let's just get the uh,
Wait, so can you guys access to the file?
Oh, yeah.
Yeah, I can't
We
access,
can't access to the
we can't access.
Oh, I was playing around with it. You can't upload, you mean?
Yeah,
Now we can literally need to ask for permission.
Yeah.
Oh, I'm sorry. I was messing around with it. Actually, I'll show you what I was doing. So, um, I actually created, um, while we're here, I'll show you what I was doing. So, uh, yeah, so here we go. Come on. Okay, so I actually created a new folder called projects and where is it? It should be in here. Projects. And over here, I listed um, what this is what we'll be doing. Let's look at the schedule. The schedule is I'll probably have to change it, but oh, we'll probably have to change it because I don't know if we did all the. But first, let me show you what the project is, and then we'll see when it's going to be. So, um, the project is that I gave everyone a design pattern to do, and I want to, so over here would be the each project, your name with the project, and then here would be a totally unrelated thing, which would be when you want to present it. And this is hard to read. Uh, I should probably change the font if I knew how to fill color. I'll just make it. How do I get back to none? Whatever. Okay, it's a little bit hard to do. Okay, so, okay, well, it's JavaScript. It's not, Okay, so basically, um, I gave everybody a design pattern. We've done so far, uh, we haven't done iterator. We have done, we haven't done state, and we haven't done decorator either. So we have a couple of patterns to do, okay? Most of them are pretty simple. Um, so let's get down to it. Okay, so that's why the presentations, the permissions were messed up because over here you're supposed to have full permissions. Let me just make sure of that. So here you're supposed to have full permission. Um, yeah, and you want this link.
Oh, we can't get in
Like,
the
even
drive.
access the file.
Oh, the whole thing, you mean? Oh, oh, that's not good. Uh, oh, I'm sorry. Should send me an email. Oh, it is. Sorry about that. Okay. The viewer, and then going back here again, just make sure. So you could upload, should be a editor.
Yeah, it should be fine.
Yeah, I went to link it editor. And then you should also be able to edit where it says projects. And um, yeah. And then over here, this is my folder. So this should be just for me. Share as viewer. Okay. It should really not be. Uh, I really don't want to uh, anyone who want to change it to restricted. Well, no, it's gonna mess everything up. I don't know why it does it. Okay. Anyhow, so this is my folder, and this is basically how I'm going to grade your projects. So basically, there's gonna be like three three parts. So the UML diagram, which we haven't covered it. I'm just telling you briefly what these things are. Then unit test is going to be 10%, and the code is going to be 80%. And the way it works is you're supposed to create a replit project. It doesn't have to compile in it, just has to have your code in it. Okay. So that way you could share it with me and I could look at it. It's just a way of sharing the code. That's simple. Uh, so you just have to give me the permission to, um, okay, so what's it called? Replit? Uh, okay, whatever. We'll get to that in a second. Okay, so where do we start? So let's start with the presentations. Okay, and then we'll move on to the, I'll give out the midterms if you want to look at it. Okay. But you notice in midterms there's a raw grade
Yeah.
and then there's a very, very uh, curved actual grade, right? Okay, you all got that? So don't freak out. Okay, so let's go for the upload. So you uploaded your
Yeah.
presentation? Okay, great. Okay, so so let's do that first, and then whoever wants to go doesn't make it. Oh, so if this thing pops, people are waiting. Uh, yes, that's the way I tell someone comes, that I hide it, and if it pops up, I know someone's trying to get in. Okay, okay, just go over here. Hey,
Can I start?
yeah, go ahead.
So today I'll be talking about SysML, which is another modeling language other than UML. But before talking about it, I would like to give a definition of what's a modeling language. So modeling language is basically a formal language that we use to visualize how a system is structured and its behavior. Why we use these modeling languages is because it helps like the stakeholders to enhance the communication between stakeholders and also detect we can detect design problems early, and also we can analyze the system before it's implemented.
Okay.
No worry. So as we can see, there's an image there of the main modeling languages. We have UML, BPMN, and of course we have SysML. Most of the languages are software really centered. So SysML was created because most of these languages were software centered, or SysML, as in system modeling language, is more hardware centered. So SysML is a modeling language for engineering systems, and it was created by the object management group, and as an extension of UML, basically. And as we can see, it supports mechanical systems, electrical systems. Uh, it can also support software, but it's mostly used for modeling and hardware stuff. Yeah, as we can see, it was created because UML was software centric. So hardware centric system was needed, and SysML basically provided that. This is the major SysML concepts. As we can see, we have two new diagram types, which is requirement type and parametric. And those highlighted in green are basically a modified version made for SysML, which allow us to accommodate more engineering systems. And the other ones are just basically taken from UML. In the real world use, we see SysML used in aerospace. For example, NASA uses it, automotive systems, robotics, and defense engineering. And yeah. So, and in conclusion, SysML is a modeling language used for engineering system for modeling, for example, parts of a rocket, for example, in NASA, or parts for cars. And yeah, it's an extension of UML, and it enables like for more system integration, like systems integration. Yeah.
Okay, very good. Yeah,
Thank you. If you have any questions, okay.
thank you.
No, no problem.
All right. So my presentation's on working on works on my machine. Honestly, when first looking at it, I couldn't really even find a Wikipedia page for it, but what most I could find is blogs and memes about it. So if you see a lot of memes, that's why. So what is works on my machine? So the best definition I saw was in a blog, which is linked in one of my references, is when a developer has written code that works perfectly fine on their local machine, but breaks down in downstream CI pipeline or in production. So CI pipeline is like continuous integration pipeline. Like you'll know there's also a continuous development pipeline. That's all automated in like GitHub and Git. So even though it seems like a meme, really it is a failure to ensure that your code behaves reliably across all environments, which is a need for because there's way more environments for everyone, way more operating system, browsers, and such. Of course, one will result in lost time, costly rework, and ultimately a delay in delivering software. Now, why does it work on my machine? Are you running the code in a different execution environment? Which we will get to on the quick anecdote section. Does your machine have different system dependencies? Are you using different browsers? Which there used to be a problem with using Brightspace on different browsers. Are you using different operating systems? And do you have different computer hardware? So the quick anecdote I had was I was making a project. It was an app in Android Studio for like scanning barcodes of food items. And on the emulator I was using for Android Studio, it was working perfectly well. And once I tried to export the APK and then use it on my iPad, well, not iPad because it's Android Studio, tablet, and then it bricks. Well, it didn't brick it just didn't reach the performance standard. So what was happening was basically that the emulator was so slow that it was doing the code correctly, which is weird to say, but like it was like basically it would scan too fast when it's not on the emulator. But if it's on the emulator, it would scan perfectly timed because of how slow it was. So, well, we just fixed that with a simple like delay. Like when it's syncing to like the scan, it just disables the scanner.
Cool.
Now, how can it be prevented or solved? So first thing is standardizing development environments with tools like Docker and Vagrant. So basically Docker is like it's like a way to export your application with the dependencies and libraries like in a thing they call a container. So it will always run in the same environment at the times. And Vagrant is like the same thing, but for development. Um it's like using everyone uses the same virtual machine while developing. So they would use the same environment and it would lead to less discrepancies. Now, implementing continuous integration and continuous delivery practices, DevOps incorporations within the teams, which emphasizes the collaboration, and managing dependencies with tools like NPM, pip, Gradle, and Maven. Gradle and Maven, I think those can be used for Java. I believe NPM is JavaScript, I'm not sure, and pip is definitely Python. But I know Gradle and Maven is definitely an Android Studio, which uses Java and Kotlin. These are just references for the blogs. And thank you.
NPM Node.js.
Oh yeah, Node, yes.
I'm not sure myself. I know I use it for Node.js.
Okay, and that is all. That is all.
Okay, very good. Someone told me like a lot of programs run on like Linux container. You read it?
Yeah,
Like even though on the PC, it will run on the container.
yeah, I think a lot of iOS is just Linux.
Yeah,
A lot of iOS is just Linux.
a lot of,
Like iOS, like iPhone.
oh, okay, sorry.
Yeah, that's good. Yeah, so today I'm going to like represent the debugging an application that crash on the remote computers. So like the application crashing is happen commonly, and there's like many reasons like in the remote computer, such as like the permission issue, like lack of the resource, and also maybe like different operating system. So because those problem because we can't access the machine, so it is more difficult to fix it when it's in remote computers. So that's why the remote debugging is useful because it could it's like a process to identify, analyze, um and we can like to know what happened like when it crashed, and we can fix it easily. So remote debugging is important because it can it can make the developer to test the application in the real world situations, like in the real world environment. Like maybe sometimes the app is working on the developer computers, but not on the user computers, like because they have like different environment. So there's like a step to for the remote debugging process. So the first step, we basically have to confirm the crash. So we have to identify the problem. The second, we have to access to the remote system, like maybe using the SSH, like yeah. And the first step, and we have to gathering the evidence to know what happened to the crash, and and then we have to analyze the crash dump or like the log to identify the issue. And then the fifth step, we have to basically to find the root cause, like maybe like there's a memory problem, like configuration problem, and then we have to reproduce the crash to make sure we understand what happened inside. Then we can try to fix it. Then we can keep monitoring the the app to make it stable. And there's like one of the main method to for the remote debugging is like the crash dump. It's like the crash dump contain like many important information such as like the memory, the error details, like the what happened, the event, and it can help us to analyze and we can study those information to um to fix the problem. And we can use the tool such as like GDB or LLDB, like it can help. It's like those like it's like evidence. We can analyze it later, even the system is not no longer running. And there's another method is like log-based debugging. So this method is like we have to insert like a um log into the important application code. Then we can recording all the user input, the value, the event, and we can understand like what happened into the crash. The log base is more is like the people like it is because it can we don't have to like connect it activity. It just like it can keep running without stopping the application. So there's some challenge, as I say like before, like the permission problem. Because it's remotely, so we can't see maybe the user input or like the interface. Yeah, so and also there's have like a limited visibility, and we can't like see everything like because it's on remotely. But the 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 remote compute is important to modern software maintenance and because like there's many app is running on the cloud servers and more frequently like in those days. So although there's like many challenge, so the remote debugging is useful for the developer to make the app on the cloud more stably. Thank you.
Okay, so it's okay. I used to work for a company where if something went wrong, they would send you to, it's like all the customers were in different places around the country. Most of them were using our software. I don't think too many of them were like where our company was located. Um, so if there was a problem, like if it crash on a system, they would just fly you down there, but they would only give you a one-way ticket. They didn't want you to come back until you fixed the problem. So that was pretty, they didn't rely on logging. They wanted you to go down and fix it. Just if anything, just to show that you're working on it, like you actually, send somebody there. So it was a little bit crazy. So thank God. I nearly got sent down to a place, but thank God I would have been there forever. So we managed to fix it by adding a lot of logging. It was a very strange error. I shouldn't say strange. It was just what the company was. They did something wrong, and like they were basically they were like a call center, and they had phone calls. They had the same phone lines for inbound and outbound calls. So people were calling in and they were making calls out on the same line. So every once in a while, they would conflict and that's when it would crash. So because they didn't know it wasn't set up properly, basically. Uh, but I didn't really know telephony stuff. So yeah, I would have never figured it out. I would have been sent there. Anyhow, I never went. So, but I did figure it out. Well, but with the help of other people who understood telephony, we figured it out together. I mean, we all actually fixed a bunch of other bugs, but the main bug, we didn't really catch. Okay, so where are we up to? Okay, so again, maybe I'll wait to end of class to give back the midterms for those who want to look at it. Okay, so let's do one design pattern right now because I was showing the projects again. So we have to do oh yeah, let's do iterator. That's really easy. Okay, so that's a real easy design pattern to get out of the way. So let's say, for example, a um, is like a very simple example. And it's also, it's really not that common anymore, but the idea is, it shows a good object-oriented idea. Okay. So basically, let's, okay, so let's do the iterator. If you do C++ and you use or C, or I think, no, or is it C++? You do the STL, Standard Template Library, right? So actually, let me just, it's, come on. Open something up. Thing froze. Come on. I'm trying to double click. Okay, whatever. Okay, now I do cancel. Okay, okay. Uh, whatever. Okay, so now I do new. Okay, no, I don't want that. Okay. Okay, so we'll start with the iterator because it's really simple pattern. Um, okay, iterator pattern frame. Okay. Okay, so the basic iterator is like, let's say example, let's use a school, okay? So we have a school, but inside the school we have teachers and a teacher has a uh, name, string, and then we have very simple, we have a um, uh, actually I'll just add a constructor. What? Okay, good. Okay, so made it really simple. Oh no, I need to get it. Uh, generate getter and setter. Okay, so then let's get rid of this constructor. Okay. Okay, so we have this teacher and then we have a school. So we're only going to have two objects, okay? A teacher and a school, and our school is going to have a a bunch of teachers. Let's imagine it has 100 teachers or up to 100 teachers. Teachers equals to new teacher should be like this, like 100 teachers. Okay. So, okay, so that's how we do it. And then if you want to, we'll make this public. And then let's do, that's not a good way of spelling. And then when we initialize the school, we'll give all the teachers names. Okay, so um, generate a constructor. Okay, so over here, we'll just have a for loop for I um, and the regular good old fashioned for loop. 0, I is less than 100, I plus plus, and we'll say, I think I have to do this again. Teachers sub I equals to new teacher. Oh, and then I have to do um, teacher sub I. And now this over here just creates the array, but it doesn't actually create each teacher. A little bit weird, the logic, but anyhow, and over here we're going to do I to string. Enter to string. I to doesn't have a to string. To string. Yay. Okay. It doesn't have it. Uh, uh, I thought everything, so I think we just do this, right? Set name. That won't work either. Uh, how do we create a to string? Um, there's no, let's see, I forgot how to do this. In Java, there's no to string method. Convert Java, convert integer to integer to string. The way you do that is you use a string dot value of. I tried that. Yeah, try this. Okay, so we do value of I. Okay, and we could do um, something like this, like teacher number, and we'll give it a I plus 1 because it starts at 0. Okay, so it'll be 100 teachers, right? So now let's say over here in main, I want to print out the teachers, right? So I create a school, right? I do school, my school equals to new school. And then if I want to print out the list of teachers, then I go to my school dot teachers. Now, I sort of have to know what it is. So I have to for int I equals to 0, I is less than 100, I plus plus, and then I have to um, print out teacher, my school that teachers sub I, right? And that will, oh, that name, that get name, right? Get name. Okay, so if I run this, it should all work well. Okay, and everything is good. Somebody's wants uh, isn't somebody trying to get in? No, I don't think so. Oh, isn't someone trying to get in? Let's see, is someone trying? No, I don't think so. Okay, hope not. Uh, anyhow, uh, yeah. So anyhow, so you see it printed out all the teachers. Okay, so what's wrong with this code? What's wrong with this code? Yeah.
Take too long to go through the whole list and print out each one by one.
Nah, we're not worried about speed. Nowadays we have fast computers. Nah. What's wrong with this code? What? No, over here it's creating the teachers with their names, and over here it's printing them. Well, it's actually the problem is that this is very tightly coupled, meaning that let's say we would inside school we would change how we store the teachers. Let's say we make it into a list or something, right? Let's say I made it into a list, right? That would break main because it's not an array anymore. It might break, it might not, I'm not sure. But it might, right? Because this is, in other words, main, it has to know, right, about the internal structure of another object. In other words, it should be transparent to main how teachers are stored, right? So this is too tightly coupled, right? So because now if I'm in school, I can say, you know what, maybe I should store them in a stack. I don't know. Anything, right? I want to change something about how they're stored. Maybe I want to make a new collection type, right? But now you have to worry about that all of a sudden you just broke what's going on over here. Like for example, I don't know, let's say I do it in a list, right? Would that break it? I'm not sure. It might break it, right? But you understand, right? Basically, it's too tightly coupled, right? It's too dependent. There's a one object should not be dependent so completely on another one, right? It should know about how I store stuff, right? So come to the rescue is the iterator pattern. So we have a pattern called um, we're going to call this the iterator. And then basically it's actually not a class, it's an interface. And the iterator is basically has only two methods. One is um, has next, which tells you it's a Boolean. So it just tells you, is there another one around? And then it has another method called next, which returns an object, which returns basically the next object. So how's this going to work? So basically the idea is within school, we're going to create a iterator, right, which is going to return the list of teachers. Okay? So basically what we're going to do is we do like this. We're going to have a private class called, let's say, teacher iterator. And this is going to implement, very important, we're going to implement iterator. Did I do something wrong? No. Uh, iterator. And, oh, I didn't do class. Wondering what. So we have this class over here, which is going to implement iterator. So we have to give it the methods, which are has next and next. Okay? So what we could do is, very simply, is we could um, we could have a variable over here called int I equals to 0. And then has next will be true if we're looking at the way this is stored, as long as I is what? Is less than uh less than 100, let's say. Okay, I think this will work. So as long as it's less than 100, meaning 0 through 99, it's going to have it will have another one, right? And then in order to um, object equals to, and then we just set this um, to the teacher sub I. And then we're going to increment, and then we're going to return the O, something like that. Okay, I probably could have done it in one step, but I just want to make it clear. Okay, so basically we're yeah, I probably could have done this. Let's just make it simple. I probably could have done plus plus. So so after every time we return the teacher, this gets incremented, right? Okay, so and now within the school class, we could have a um where is this? We could have a method called return school teacher iterator, um, or just something called uh, um, something that returns a iterator, and it's called, let's say, get teacher iterator. And all this does is return the new um, this one over here. And then over here within main, instead of having this for loop, we would actually have we do this. Well, I could leave this here, but we have another way of doing it now, a better way. We could have my school dot get teacher iterator, and it's not important to know um, teachers. My school got teacher iterator, and then we could just have a loop called while um, while teachers has next, then I'm going to, let's say, print out um, um, te teacher teachers that next, and then oh, I have to cast it to a teacher, unfortunately, and then I have to. This just so compiles, and then over here I just do get name. Okay, so the difference is that now we're basically relying on the interface to go through the list, rather than over here, we had an intimate knowledge of how it was stored. So we should get the same list, right? But over here, the second way, even if we change how it's stored, right? When we change this, how it's stored, what the school would have to do would be to update this iterator, right? But no code outside of this object would have to be modified, right? So the benefit of using an interface is that that anybody outside the school doesn't know and doesn't care how it's stored, right? The actual implementation details are hidden from the consumer, which would be over here, right? Because over here, we don't care how it's stored. We always have the same two methods, has next and next. Let's see if it works. It might work, might not. Sometimes I'm off by one, so I think this might work. So yeah, it worked. I think it worked. Uh, yeah, started at teacher one. Yeah, it worked. Teacher one, and it went up to teacher 100. Yay. So, so, so this way is a generic way, okay, using a interface rather than using the actual object that's stored inside the the school. Does that make sense? Right? It's much more flexible, right? Any questions at all? Or so this is the iterator pattern. Okay. Are we good? Okay, so what other design patterns are there? For the projects, I think oh, we could do one more, the decorator. Okay, the decorator is is also not too complicated because I'm going to present it to you like in more of a like when you look it up, you'll see it's a little bit more they present it more complicated, but the idea of the decorator is that you could chain objects together so you don't really have to know how many objects there are. So here, I'll show you real fast. Okay, is this good? So this is a simple pattern, right? Okay. Um, I guess do decorator. Um, I'm going to do the simple way. There, if you look it up though, there's going to spring 2020. Okay, so let's say imagine we have does everybody know, so you know what logging is, right? You basically write a message of the state of your program to you write it somewhere, right? But there's actually many different ways to log. You could log to a file, you could log to a database. Logging just means to send out information or about the state of the program, but it doesn't really specify how you're going to do it. So we have different types of logging, right? For example, we could have the most common one, I guess, is a file logger. And let's say the file logger will have a method called log, and it'll take a string, make this public, it'll make it void, and it'll log a message, and it's logging to file, right? And okay, maybe I'll even put in the message, logging to file, and then plus MSG. Ah, there we go. Okay, so this would be a file logger, and then we could have there are lots of different loggers. Um, you could have a terminal logger. That's another common one, which is basically the terminal logger means that like while the program's running on one machine, I can watch it on my machine in real time. That's pretty cool, right? So, so we can have the terminal logger. Just gotta change that name here. Logging to terminal. And let's just do one more type of logging to databases. Okay, that's another common one. Okay, so these are like probably the most common ones. Okay, another one would be a database logger. That means that it saves the, as it's running, it writes to the logging to database. Okay, now, so what is the issue? The issue is that we have these three types of loggers, right? But the problem is that, let's say we want, why is this giving me a problem? Too many of those. Okay, so the problem is that often you want to mix and match, meaning sometimes you want to log um, to every logger. No, let's say it's a serious error. You want to save it to the database and to a file and the terminal. Sometimes you only want to write it to a file if it's just like informational. Like they're different. But the problem is it's going to get complicated, right? If you have all the, how do you, like you say, if it's this, you'll have something like, um, you could end up with something like this. So you might have like um, log error, and then within log error, you would have a log, and then you would have a int level um, with public um, void. So let's say 0 equals serious, and then 5 would be, or 10 would be just informational. Yeah. So if you pass in a level 0, that means it's a real serious bug. If you pass in a 10, then it's informational, right? So, um, so for example, they say if level equals to 0, then you want to do all the loggers, right? You want to do database logger equal to new, um, or I just want to do something like this. I'll do new database logger dot log the, oh, got the message. And then if it's, let's say, and then I want to do the terminal, and then I want to do the, um, what was the other way? File, right? But if it's 10, I only want to do the file. Okay, that's all I want to do. So basically, this is a this this is one way to do it, but it okay. So basically, the idea is that we have this method which decides which loggers to call based on the level, right? Okay, the question is there a simpler way of doing all this? And the answer is yes. And what would that be? Well, the decorated pattern says, well, what we could do is we could actually create we could actually create remember, how do we join things together that might be separate, but they have similar methods? What do we use? Exactly. So we use a log interface, right? So we use a very good log interface, and it has one method called log, and it takes a string and it does a message, and then it's void. Okay, So, so how does that help us? Well, first of all, it can make all of them, it could, okay, it can make all of them, now we could treat them all, they were all, they all implement the log method, so we could treat them similar, right? And you'll see in a second why that's good. So, right, we're not doing it just because it's fun. We're doing it because we could do is when we create the terminal logger, we could actually, we could do is over here, we could have actually, let me change the name from log to logger. What did I just do? Uh, Implement. I'm gonna make it logger. Okay. It's a little bit more, fits in better. Because log is like a method, right? So it should be logger. Okay, I'll just change the name of the file. Okay, so now what we're going to do is we're going to allow one logger to know about another one. So for example, inside the database, I'm sorry, we're going to do is we're going to put a reference to a another logger within each of these. Okay, so we're going to go over here and we're going to let each logger know that there's another logger lying around. It could be. There could be another log. Now, by default, it's going to be, it won't have any value, right? But then when we create this logger, okay, by the way, there are better ways to do that. I just, in the interest of not confusing you too much, um, so within this logger, we can say this dot logger equals to logger. So basically, what I'm doing is I'm allowing the terminal logger, right, to, um, oh, I forgot. It doesn't. Okay, so this is not going to work. Let me just comment this out. It's not going to work. Actually, I'll just pass it now. Because now it's looking for a pointer for a previous logger. So we're map to. So terminal where it was? Yeah. So over here, it's looking if is there another logger besides me? If there is, we pass it in. Okay. And then when I log over here, before I log, the first thing I do is I say if there's another logger uh, is not equal to null, then I'm going to log the message to them. So in other words, what the idea is, and this I'm going to repeat this over and over again. So basically, every logger now is going to actually look to see if there's anybody else that's before me. And if there are, then I'm going to call them. And then only after I call them will I do my own logging. Okay, let's do another example. Let's do the database logger. So it's the same idea. So, okay, so I look to see. Oops, I didn't need that. So I look over here, I look to see if there's a data. Okay. So over here, same idea. Before I write to the database, I look to see if logger is not equal to null, then I'm going to call that logger first. Or I could do it second, but usually it's first. Okay. And I'm going to do the same thing over here by the file logger. I'm going to say that file logger is going to take public. It's going to take a logger and this that logger equals to logger. And then I check to see if there's another logger. And if it is, I call it. So I say if logger is not equal to null, then I'm going to log that one first. Okay, so, oh, good. Wow, everything seems to work. So what did I gain by all this? Well, what I gained is that within, um, well, let's say over here, what do we gain? Let's say over here, I want to log to 3 loggers, right? I could rewrite this now like this. I could say that I could have a I could have a logger uh, over here. And then if the level equals 0, then I could have something like, it looks like this. I could have logger um, equals to new, and I could say new database logger, but within new database logger, I could pass in terminal logger, and within terminal logger, I could say a file logger, and then pass in and then wait a second, and then I'll pass in null because there's nothing before that one, and then over here, I could just do this. And then at the bottom of my code, I could say um, logger um, dot log, and I do the message. So basically, what I did was what doesn't it like? Oh, I said I should initialize it to null. Okay, so the idea is that um, by doing something like this, what I'm accomplishing is um, when we get to this code over here, this line doesn't know how many loggers there really are, right? Because this logger is actually pointing to 3 loggers, right? And then this one is pointing to only 1. But the point is, the code over here on line 19 doesn't care how many loggers there are, right? So the idea is that we could pass this logger around as a parameter to other methods, right? So for example, um, we could return a logger if we want to, right? So we could like return the logger, and then the rather than logging it, we could just return the logger, and then the the person who's getting the logger has no idea how many loggers there really are, but they don't care, right? All they have to do is just call logger and we can pass it around, right? As if it's only one. But in reality, they're all chained together, right? Because when we call, so for example, let's say I would do log error, say in main, let's say I would do um, log error um, um, just to do this new log error, and I would do um, new log error dot log. It really wouldn't be called log anymore. It'll be called create get logger, and I would pass and say 0, right? So then, um, and then I would call um, okay, let me just fix this up. So now it's going to be get logger instead of log. And then over here, I could just say get loggers for level 0, and I would call log uh, catastrophe. Catas, cat forget how to do things with AI, right? Like spell. Okay, so now if I so now I'm getting a logger, but I don't care how many there are, right? And I could pass this logger all over the place, right? So I could pass it to other methods, right? And I don't need to be stuck, within this method over here, right? This is just deciding how many loggers to actually give me. So if we would actually run this, we'll see that there's actually 3 loggers, right? And it only did one. I did, wait a second, log is 0. Oh, 10. Okay. Right. So that's not a catastrophe. That's the other way around. No, if level equals 0, so why is it only doing, oh, this should be 10. Sorry. Uh, yeah, so, and then if it's 10, it should just be informational. If it's level of 10, it'll just be an informational. Informational. Okay. By the way, I think after today, we're going to be on break, right?
Yeah.
Okay, spring break. Okay. So I won't see you for a while. Uh, oh yeah, I'm sorry. Okay, so here, right? So first we did catastrophe, and then so log to three places, and over here it did it to only one place. But 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 from my perspective, it's only one logger, right? Under the hood, each loggers are chained together and they call the other one, right? The but the nice thing is that from my perspective, um, I don't have to know about that complexity. All I know is there's one logger, I could pass it around and treat it as just one, even though there might really be 5 of them, right? So you'll see in the book they're gonna or the book or on the web, a lot of them have to do with coffee. It has to do with like you add stuff to your coffee cream and then you add sugar or cream, different that's why it's called decorator, like you're like adding things to your coffee. Yeah.
And is it Java called Java because of Java beans?
Right, right. So, right, very good. Yeah, but the decorative pattern is specific to. I mean, you'll see there's a lot of coffee examples with because like you just and then what happens is you just say something like the reason I use the logger example is because at work, that's what we use. Meaning that we use something called log for net or log for J. It's the same library, and this is how it works. Basically, you have a config file. The config file sets up the loggers for which level, and then you just call, log, and it does its own thing based on, but you don't really know what it's which how many loggers are being created. Like the programmer doesn't care, right? They just pass in, level, and then they log. They don't like I don't know what's gonna happen when I do it. It might log to 5 places, might log, right? That's up to the config file, right? So the config file, where that's how log for networks is you put the levels and the which loggers are called for which level in a config file, and then it actually could be changed at runtime. So while the program's running, it could change where it's getting logged to. Yeah, someone could change the config file while it's running, and it'll pick up the changes, and then it'll log to different places, or you can remove places it's being logged to. Like, let's say your database getting full of, let's say there's an error happening over and over again, it's filling up your database, right? That's always the danger of writing to a database. So then you could like quickly go to config file without stopping the program, and you could just remove that entry that says write to the database, so you could do stuff like that. So that's pretty cool. So, but the programmer has no idea that what's really going on, right? Because it's up the config file that controls what actually happens for each level. Okay, so I have the midterm, okay? And I guess I'll bring it next time also. Um, and have a nice spring break,
Alright.
okay?